Okay, now let's take a look at some real-life examples to write our quadratic equations. Jude, he threw a foul shot. He released it at 6 feet with a velocity of 20 feet per second squared. Now, because we're talking about feet, our A value is going to be 16, negative 16. Our velocity is 20, and our y-intercept is 6. So let's remember, T is for seconds, and h of t is our height. So we can figure out any height by plugging in seconds, or we could also, if we know how many seconds goes by, we know how high the ball is. So the y-intercept in this situation represents the launch of the basketball at 6 feet. The vertex represents the total amount of seconds it takes the ball to reach the maximum height, and my 1 positive 0 tells me how many seconds it takes for the basketball to hit the ground. The initial height, 0,6. Remember 0, our x is seconds, and our output is height. In this case, we're talking about feet. What is the maximum height of the ball? Well, in order to get the height, we have to know the seconds. Okay, the maximum height is the y part of your vertex. So we need to get the x value first. Negative b over 2 times a. Use my calculator. So again, please have your calculator handy. And we get 0.625. Okay, so that is going to be the seconds. Now we're going to plug this x value into our function. 0.625 squared plus 20, again replacing t with seconds. So now let's use our calculator, parentheses when needed. We have negative 16 times 0.625 squared plus 20 times 0.625 plus 6. And we get about 12, we get 12.25 feet. Okay, so this point is 0,6. This point is 0.625, 12.25. That is the vertex. And then now it's asking, what is the height? So h sub t after 1 second. So when 1 second goes by, how tall or how high is my basketball? So we're going to plug in 1 for time. I get so used to saying f of, but let's just do h. When I plug in 1, I get negative 16 plus 20 plus 6. That's 26 minus 16. That gives me 10. So it's 10 feet after 1 second. So if you wrote that as ordered pair, it'd be 1, 10. Okay, how many seconds will it take to reach the maximum height? Well, this is the x part of the vertex, and that was 0.625 seconds. Let's always use our units. How many seconds will it take the ball to land if it is an air ball? So if it doesn't hit the backboard or the goal and it hits the ground, so we need to find our x-intercept. We know this x-intercept is negative and it's irrelevant. So we're going to use the quadratic formula. We're going to say negative b plus or minus b squared minus 4 times my a value times my c value all over 2 times a. Let's clean this up a bit. 20 squared is 400. Now let's establish the sign here. What operation? We have a negative times a negative, so that's going to be plus. And then we're going to calculate 16 times 4 times 6. And that gives us 384. And then we have negative 32. When we add these together, we get 784. And now we're going to have two equations, two roots. We're going to have a minus, and we're going to have a plus. That should be a 20. Okay, so we have two equations. Here's one, and here's the other. So we know the one that's negative is irrelevant. So let's calculate. Negative 20 minus the square root of 784. And then we're going to divide it by negative 32. That gives me 1.5. So this one is 1.5, so it's positive. So it's going to take 1.5 seconds for the ball to land. There's no need in calculating this one because we would get a negative value and it would be irrelevant. Okay, how many seconds will it take the ball to hit the 10-foot goal? So we want to know at 10 feet, how many seconds will it take for the ball to hit at 10 feet? So we're going to use the quadratic formula again, but remember, when you use the quadratic formula, our equation must be set equal to 0 because we're looking for the x-intercept. So let's subtract 10, and we have negative 16 plus 20 minus 4. Negative b plus or minus b squared minus 4 times a times c over 2 times a. 400. And then let's establish we have a negative times a negative times a negative. That's going to be a negative. So I know 4 times 4 is 16, and 16 times 16 is 256. And when we subtract, we get 144. Ooh, that's a nice perfect square. Square root of 144. So I'm going to come over here. I'm going to have two equations. Negative 20 minus 12 over negative 32, and negative 20 plus 12 over negative 32. So let's do both of these. This is when the ball is 10 feet in the air. How many seconds? So we get 0.75. Okay, again, we're talking about seconds here. We plugged in 10 feet. And 0.25 seconds. So we have two answers. Again, remember you have, here is our axis of symmetry, and at 0.25, the ball is 10 feet in the air, we'll say right here, and then at 0.75, it's coming back down and it's still 10 feet. So that's why you have two answers.